So we're almost done here with sensory. Let's take a look at how the rods process signals. That was the tail end of the previous section. And so basically in the dark, you have sort of this steady stream of neurotransmitter that's being released. And that's the reason for that is so here the rhodopsin is intact and calcium channels are open. Influx of positive charges creates sort of this membrane potential at a certain rate, and that is sort of this steady state kind of default release of neurotransmitter that signals, okay, it's dark. So now let's see what happens when it's light. Now light hits the rhodopsin, and that in this case leads to a decreased level of cyclic GMP, and it closes this calcium sodium channel right here, which means the influx of positive charges stops. Now we're hyperpolarizing, so we're getting more negative because we're missing the influx of positive charges, and that actually leads to less release of neurotransmitter, which is then perceived as a change from previous. So a lot of times sensory neurons, the signal change from a previous situation. So here in this case, now let's put it all together. In the default, in the dark, we have a certain amount of neurotransmitter released leading to a certain amount of action potentials. That's default. In light, there's a reduction in action potentials that are transmitted, and that is perceived in this case as a light input. And then here, the photoreceptor will return to sort of its steady state, and it's in its recovery phase, and we need to put the rhodopsin back together from opsin and retinol. Okay, and here basically one more time this whole issue of convergence. All of these rods here, they synapse to two different bipolar cells, and these two, they will synapse to one ganglion cell. So you can tell that the visual acuity is just not going to be that good because your brain has no way of telling which exact rod or set of rods has fired or sent a signal. Now, I'm finishing up with signal processing. So we're going to put it all together. We're starting out with light hitting your cornea, then the lens, then the retina. In the retina, we are then we have photoreceptors, rods and cones, which will then send action potentials, either increases or decreases of action potentials to bipolar cells. So the photoreceptors converge to bipolar cells, then they converge to ganglion cells, and then they in turn these axons become the optic nerve. And then we'll take it from there in the next slide. So here's still this whole convergence issue here one more time, but I think we were kind of done with this. So let's follow up here. Light stimulus hits the retina. So first to the cornea, then the lens, then we hit the retina. First are the photoreceptors, rods and cones, then bipolar cells, then ganglion cells. Then we bundle all of this up to the optic nerve. Half of the signal from each optic nerve will stay on the same side. The other half will cross over at the optic chiasma, which is left out here. So the optic chiasma you would have to fill in here. And then the optic tracts will get us to the thalamus with the lateral genicular nuclei. We also are missing here the superior colliculi of the corpora quadrigemina. Eventually, everything is being put together and sent to the visual cortex and the visual association cortex, where we then process the signal. So you're going to have to put this slide here together with the next one, which shows the parts of the pathway that are not seen here. So here we have rods, cones, bipolar cells, ganglion cells, and optic nerve. And here you can see more clearly how half of the signal from the optic nerve crosses over. See these red dots? Half of them will cross over here at the optic chiasma, the other half will stay right here. And the green line, same thing. Half of the green signaling here from this from the right eye will cross over and go in this direction. The other half will stay here on the right side. Then we have the optic tracts, of course, here. So optic nerve, optic chiasma, optic tracts. That was left out over here. So that's this part right there. And then we have the lateral geniculate nuclei, the superior colliculi, which are also not mentioned in this pathway right here, so that will be over here. So the that's over here, the superior colliculi of the corpora quadrigemina, the optic radiation, and then in the end, that is also in the previous slide, the occipital lobe, the visual cortex, for sort of putting it all together and giving you your visual input. Now we're almost done here. Let me just show you some visual illusions here. If you stare at this long enough, these circles will start to move. Of course, they're not moving, but you have the perception, and that is because your brain makes up a lot of stuff. You're learning things as you're growing up. You learn how to process signals, and then your brain really only evaluates a very small percentage of the available signals because it just can't process all this information so fast. So a lot of things, you just glance at it and your brain makes up the rest. You are processing a very small percentage of the total amount of signal that's available. Here, your brain automatically makes up that the green line here in the back is much taller than the green line here in the front, but it's not true. They're both the same size. It's just you have the perception because this green line is farther away, so it's got to be taller. Or here, the question is this a rabbit or a duck? Well, it depends on which perspective you're taking. So if you're thinking that it's a rabbit, then these here are the ears of the rabbit, and that's his eye, and there's the front. If you're looking at it as a duck, then this would be sort of the mouth of the duck. Anyway, just stare at it, see what you think. Here's my last slide. This one is interesting because we also have these perception of the shading of different surfaces. If you take a pen and you cover the line here between the two surfaces A and B, then you will see that they are exactly the same shade of gray. Now, if you are having this white part visible, then surface B will be a lot lighter than surface A. But take a pen, cover up the center here, and I'm not sure if you can see that, but I'm covering it up. And once you're looking at, if you are covering up this bright area right here, then you can see that both surface A and B have exactly the same shading. Anyway, hope you learned something from this lecture. Review this because, of course, this will be on your next unit test, and your next unit test will come up after we cover the autonomic nervous system, which will be your next lecture, and then we still have muscle and the endocrine system left. But just keep in mind that the next unit test will be coming up soon.